The approach in this problem is very similar to the one we use for subsets 2, because we have a similar situation where we essentially want to find all unique combinations of numbers, but we want to make sure that we have only distinct combinations, and we're not guaranteed that the numbers and candidates are all distinct. So the way to go about this is to ensure that we do not repeat any combinations. Similar to subsets 2, we can start by sorting our candidates array. And then, similar to combination sum 1, we can have a result list, which we will add to whenever we find a combination whose sum is equal to target. And we'll have like a helper method, which will take in our candidates, target, the result, an empty array list, which is going to represent the current combination, and also the index, which we will start at 0. In the very end, we want to return res. So in our helper method, we can start by considering the base case, which is, first of all, if target is equal to 0, then we know that we have a combination that sums up to target, because we will be decrementing from target every time we add a number. So in this case, we want to append a copy of our current combination to our result, and we want a copy of our current list, not the actual list, because otherwise we could run into some issues with reference semantics. Then we want to return, because this combination we already know works. And the other base case is if our index is greater than or equal to the candidates.length, we want to make sure we stop recursing, because otherwise we could run into an index out of bounds error. And the other situation is if our target is less than 0. In this case, we're never going to sum up to target because we've already overshot, so we just want to return. Now we can consider the situation where first we exclude the number at our current index. So if we exclude number at current index of candidates. So essentially what we can do is, if we want to exclude a number, similar to how we did it in subsets 2, we want to exclude all the numbers of that value. So I'm just going to keep a copy of what the index is, and while the value at index plus 1 is equal to the value at index, this means it is the same value because, remember, we sorted the array initially, and we also want to do a check to make sure that this is within bounds. In this case, we just want to increment index. So now that we have adequately incremented index until the last value at which the current value is equal to the value at index, we want to call this method again. And remember, we're excluding the number, so we do not subtract from target, and we do not add anything from to current, because our current list, because we're not adding anything in this case. And then we just want to increment index, because once we increment index, that's going to be the first value that is not equal to the current value at candidates of index. And then we can consider the case in which we include number at current index of candidates. So remember when we kept a copy of what index was? We can now use that to basically in our call for I+1 for our index, because when we do want to include a number, we don't want to move to the end of where this value is. We want to be go directly to the next value. So we're just gonna subtract the value from target because we are including this number and we want to consider it in our sum. Res and cur, and then we're going to do I plus 1. And we also want to make sure to add this value to cur. In the very end, we had to do a backtracking, so we remove the last value in our current array or list. And yeah, here we are. And it looks like there's a small syntax error somewhere. Oh. Okay, cool.